During the late Kangxi period of the Qing dynasty, Taichung Port was known as Wuqi Port. During the Japanese colonial period, it was called Niitaka Port. After being taken over by the nationalist government, it was renamed Taichung Port. At that time, Mr. Cheng Qingque, who was the premier of the executive Yuyuan, was actively promoting the 10 major construction projects, and Taichung Port was one of the key projects among them. Taichung Port spans across Longjing District, Wuqi District, and Qingshui District, with a water area of 8,382 hectares and a land area of 2,903 hectares. On October 31, 1976, the grand opening ceremony for Taichung International Port, constructed on the central west coast of Taiwan, was held. On that day, nearly 300,000 people from all directions gathered to visit. Both inside and outside the port, crowds of people surged, all filled with immense excitement to share in the achievement of this great construction project. The Taichung Port project is one of the 10 major construction projects of the Republic of China government, and it is managed by Ret-Ser Engineering Agency. It is a rare gigantic artificial international port constructed on a sandbank. Originally, this area was a flat beach with no natural barriers, making it completely unsuitable for harbor construction. It entirely relied on human effort to build seawalls and wharfs in the sea, making it a massive feat of land reclamation. The project was scheduled to be completed in 3 phases over 10 years, with the first phase being one of the 10 major construction projects. The main components of the project include the coastal road, south and north breakwaters, south and north sea walls, dredging of the navigation channel, construction of deep water wharfs, and 7 berths. The primary purpose of the government's construction of Taichung Port was to adapt to economic development, meet the increasing needs of import and export trade, and reclaim land for the construction of offshore industrial park to promote industrial development in the country. In order to undertake this great construction project, RSEA established the Taichung Port Construction Office as early as May 1973. It mobilized a large number of new construction equipment and skilled personnel to participate in the construction. The pioneering project of port construction began with the construction of roads on the sandy beaches within the port area, serving as the main arteries for the transportation and supply of all machinery and materials. The primary construction material for port construction was various sizes and shapes of stones, with large boulders weighing over 1 ton being exclusively blasted and extracted from Guguan, located 60 kilometers away from Taichung Port. These stones were chosen because they were the closest available and possessed exceptional hardness, meeting the standards required for port construction. To ensure an adequate supply of stones, RSEA established a well-equipped cobblestone processing plant along the banks of the Dejia River. The plant processed cobblestones extracted from the riverbed, producing materials essential for riprap and precast concrete. This fully automated concrete batching plant is located in the windbreak area of Taichung Port. During peak construction periods, it can produce over 1,500 cubic meters of concrete per day. Another preparatory work for the port construction project is the precasting of tribars and tetrapods ranging from 3 to 5 tons, which are placed along the road in preparation for future lifting and placement during the construction of seawalls and wharfs. The construction of the caisson dock and the working vessels dock commenced earliest, both being preliminary works in the port engineering project, primarily constructed using steel sheet piles and diaphragm walls. The design of the small breakwater for the working vessel's dock adopted the latest method of diaphragm wall construction, which was a pioneering attempt in harbor engineering at that time. Its main advantages were rapid construction and cost savings, proving to be sturdy, reliable, and effective. Concrete anchor plates were embedded to secure the sheet piles, making them more stable. In essence, the working vessel's dock served as a small harbor, measuring 300 meters long, 170 meters wide, and with a depth of 4.5 meters. Its purpose during the initial stages of port construction was to serve as a berth for the working vessel fleet, essentially serving as the base for future construction activities. The construction of Taichung Port involved simultaneous operations at sea and on land. To initiate maritime operations, RSEA mobilized over 70 maritime vessels, forming a sizable fleet. Taichung Port is an artificial port constructed entirely by manpower on the beach, making the dredging project's construction task crucial. Furthermore, to prevent external sediment from flowing into the dredged harbor area, it was decided to commence construction with the turning basin. RSEA mobilized 5 dredgers from the outset, simultaneously dredging the waterway and roadsteads while filling the dredged sediment into the newly created land in the port area. The dredging operations primarily utilized cutter suction dredgers, with the largest dredger boasting a main engine power of 9,200 horsepower. The newly created land from this dredged sediment totaled approximately 600 hectares. Consequently, part of the sandy beach was transformed into navigable channels, while another part became the foundation for constructing wharfs and warehouses. The construction of the caisson dock involved driving steel sheet piles and steel pipe piles first, followed by gradually pouring concrete into the bottom and walls of the dock. The caisson dock is 105 meters long and 28 meters wide, serving as the construction site for producing caissons during the port construction period and later serving as a shipyard for ship repairs after the port is completed. The expansion of the outer seawall in Taichung Port is the most challenging part of the entire port project. The so-called outer expansion seawall includes both northern and southern breakwaters, northern and southern inner dikes, as well as a northern sand dike and a southern seawall. Among them, the southern seawall has the highest volume of riprap. Originally scheduled to be completed in 2 years, it was actually completed in just over a year, bringing the two ends together, which is a remarkable achievement attributed to the hard work of the construction personnel. Each seawall and breakwater is then constructed according to the specifications in the construction drawings, with layers of tribars or tetrapods being laid. All of the tribars and tetrapods are neatly arranged one by one, enhancing the wave resistance of the structures. Due to the urgent schedule of the Taichung Port project, it was not feasible to wait until the caisson dock was completed to manufacture the caissons. Therefore, with the ingenious use of engineering personnel, a solution was devised, manufacturing the caissons directly on the beach. The advantage of this approach is the ample space available on the beach, allowing for the simultaneous production of multiple caissons after reinforcing the beach area. This is unlike the caisson dock, where only up to 4 caissons can be produced at a time. These rectangular objects, completely cast with reinforced concrete, weigh over 3,000 tons, with heights and volumes exceeding those of a 7-story apartment building. The challenge lay in how to drag the completed caissons from the beach into the water. After extensive research by construction personnel, a method was devised using cutter suction dredgers to excavate the sand from the front end of the caisson's bottom, allowing the caisson's weight to gradually slide forward until it completely slid into the water and floated on the surface. This was a bold attempt, and its successful outcome was highly satisfying. Of course, caution was essential during the construction process, as there were inherent risks. Premier Cheng, head of the executive Yuyuan, was deeply concerned about the Taichung Port project. He visited the site on 12 occasions, engaging in friendly conversations with the RSEA staff each time, and offering warm words of encouragement and appreciation for their hard work and dedication. For the construction of composite breakwater with caissons, the first step is to lay out markers at sea and conduct underwater surveys. On the seabed foundation for riprap, synthetic fiber cloth is first laid to prevent scouring, before which riprap operations can commence on the designated foundation for placing the caissons. Since the lower layer of riprap beneath the caisson foundation is thick and can be piled up without needing to be leveled, bottom-dumping hopper barges are mostly used for riprap placement. As for the upper layer of smaller stones on top of the riprap, because of their thinner thickness and the need for a smooth riprap surface, grab dredgers are used to evenly distribute the stones, dumping them basket by basket. Underwater leveling begins with the rake of a leveling craft slightly smoothing the riprap surface. However, merely using the leveling ship is insufficient. The primary operation relies on divers descending to the seabed for detailed leveling work. The seabed under the caisson foundation ranges from 5 to 20 meters in depth. Diving operations for seabed leveling are not only extremely laborious but also very hazardous. Once the underwater leveling is completed, the caissons can be officially placed. The placement of caissons requires selecting optimal weather conditions with calm seas, ensuring seamless coordination between all offshore and onshore activities for the smooth execution of the deployment operations. The first caisson for the expansion of the seawall at Taichung Port was placed immediately following the riprap section of the northern breakwater, and its precise positioning was a resounding success, bolstering the confidence of the construction personnel. The positioning of each caisson involves continuous adjustments of its location and gradual flooding to allow it to settle into place correctly. Once the caisson is properly positioned, the riprap placement resumes immediately to connect it to the preceding caisson. After placement, the caisson is filled with sand and gravel. Through their on-site experience, construction personnel devised a method known as island hopping to expedite progress. This method involves placing a caisson at a predetermined position beyond every fourth or fifth caisson placed. However, since there is no support during the placement of these isolated island caissons, the construction process is more challenging. These caissons are then sequentially placed towards both ends from this solitary caisson to close the gap. The advantage of this construction method is that it increases the work surface for caisson placement, allowing for the simultaneous placement of 2 or more caissons. However, it requires precise measurements and close coordination in all aspects to be successful. The tidal range at Taichung Port is particularly large, alternating between rough seas and calm weather, with strong underwater currents often present, posing significant obstacles to offshore construction operations. Subsequently, due to the proficiency of the workers, there have been records of completing the placement of 4 caissons consecutively within a single day, breaking the world record for similar construction methods. Chairman Chao Chu-Yu of Veterans Affairs Council and Director Yen of the RSEA regularly visit the Taichung Port construction site to encourage and motivate the construction personnel, urging them to tackle the task entrusted by the government with utmost confidence, determination, courage, and unity, striving for honor on behalf of all retired military personnel. In the first phase of the expansion project at Taichung Port, the majority consists of composite breakwaters made of caissons connected one after another. The total length of all seawalls is nearly 8,000 meters, with 3,000 meters consisting of composite breakwaters. The diligent and hard-working spirit displayed by the staff of the RSEA in the construction of Taichung Port has earned praise from all quarters, demonstrating their determination and courage to take on any challenging task. Composite breakwaters are gravity-type breakwaters that rely on their own weight for stability, requiring extensive stone filling work. It takes an average of 36 hours to fill each caisson. After the stone filling is completed, to protect the foundation of the caissons, the sides are raised further, and each side is fitted with 50-ton concrete blocks to prevent loosening due to wave erosion, ensuring a more stable position. Additionally, large stones brought from Guguan are further placed, requiring hard and angular characteristics to withstand the impact of waves, some even requiring additional protection on the surface with tetrapods. The purpose of all these protective measures is to establish a solid foundation that can withstand a century of challenges for these seawalls. In the joints between caissons, underwater concrete is poured to link them together, and finally, the tops are sealed. Only then can the composite breakwaters be considered successfully completed. The composite breakwaters, including the South Breakwater and the North Breakwater, stand as the northern and southern ramparts guarding the outer reaches of Taichung Port. In the construction zone of Taichung Port, there are over 5 months of windy seasons each year, often accompanied by swirling sands and stones. The strong winds sometimes make it difficult for construction workers to even stand, but in order to meet deadlines, they cannot stop working due to the seasonal winds. Instead, they don headgear and goggles, enduring the harsh battle against the wind and sand, often starting work at dawn and continuing until dusk. Their diligent work ethic is truly admirable. Several typhoons in 1975 and 1976 caused varying degrees of damage to the Taichung Port project. Although the seabed at some construction sites was affected by strong winds and currents, causing erosion or sedimentation, the completed caisson foundations remained steadfast against any onslaught of strong winds and waves, demonstrating remarkable resilience. Among the main construction projects, including dredging and filling works and the expansion of the breakwaters, the Wharf project stands as one of the three main components. To facilitate construction, pre-stressed concrete piles were manufactured on-site using the pre-tensioning construction method. Steam curing operations were adopted to achieve rapid and quality-assured production of the piles. In the first phase of the project, 7 wharfs were scheduled to be built, with the 5th to 8th wharf being trestle-type wharf, totaling 800 meters in length. The retaining walls behind the pile caps were constructed using precast methods to prevent the land behind the terminals from collapsing or subsiding due to wave erosion. In addition to installing tie rods, cap beams and cross beams were added to the upper part, followed by pouring concrete to form the wharf deck. These wharfs are designed for general cargo ships with capacities ranging from 30,000 to 50,000 tons. The caissons for wharfs 1 to 3 have a design height of up to 17.9 meters. To facilitate launching, they were completed up to 10 meters on the beach before being towed into the sea for final assembly. Although the volume of wharf caissons is larger than that of the expansion breakwater caissons, the construction process for manufacturing and placing them is similar. First, the foundation is prepared by leveling and stone pitching, then the caisson is filled with sand before the wharf works commence. The difference lies in the fact that pier caissons are constructed within the harbor, unlike breakwater caissons which are placed in the open sea and thus face threats from wind and waves. While the construction of Taichung Port was underway, representatives from the United States Army Corps of Engineers and Petrola, a Greek company, visited the construction site in 1975. In October of the same year, the U.S. Army Corps of Engineers invited RSEA to negotiate and undertake the construction of the Jeddah Naval Base in Saudi Arabia, marking RSEA's entry into international port engineering projects. The Jeddah Naval Base project had a total cost of $300 million, approximately 8 times the budget of Taichung Port. Subsequently, RSEA successfully undertook various overseas port and maritime projects, including the Control Tower and Yacht Marina at Jeddah Port, Songkhla Port in Thailand, Diego Garcia Naval Base in the Indian Ocean, Surabaya Port in Indonesia, the Mediterranean Sea Dike Project in Egypt, and the expansion project of the Port of Sed, among others. Establishing itself as a renowned international port construction company, RSEA's collaboration with the U.S. Army Corps of Engineers facilitated its involvement in multiple military projects in the Middle East, further enhancing its reputation globally. The construction of Taichung Port can be seen as a prime example of human triumph over nature and a cornerstone of RSEA's international success. The completion of all major construction projects in the first phase of Taichung Port was officially announced on September 30, 1976, 1 month ahead of schedule. This achievement was made possible by the collective efforts and round-the-clock work of the RSEA workers. It allowed Taichung Port to commence operations on October 31, 1976, underscoring the versatility of human hands and the adage that human effort can overcome any challenge. The opening of Taichung Port not only relieved congestion at Keelung and Kaohsiung ports but also alleviated the burden on railway and highway transportation. Following the completion of the first phase, RSEA continued to undertake the second phase, which included projects for commercial and industrial port channels, land development, and various wharfs. Until today, Taichung Port has become the second largest port in Taiwan, integrating industries such as commerce, industry, fisheries, and tourism. It has evolved into a comprehensive international port, holding a significant position in our country's economic development. It's hard to imagine such prosperity emerging from a coastal sandbar, overcome by the relentless winds and waves by our RSEA staff in arms. The spirit and efforts of the RSEA staff who silently contribute to the nation should be passed down and shine brightly alongside the sun and moon for eternity.